Hello everyone, today we are going to solve question number 2, add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return the sum as linked list. You may assume that the two numbers do not contain any leading zero except the number 0 itself. Okay. In this video, I'm going to discuss three methods to solve this question. Okay. So First, let's see the goal of this question. Okay, so when an integer like 342 is given to us, it's stored in this fashion, where each of these digits are stored inside one node and the number is stored in reversed order. Okay, and we all know that while adding two numbers, we start from ones place and go till the hundreds or thousands place. Okay, hence this question already helps us in giving the numbers in reverse format. Okay, so our main goal is going to be we have to add these numbers and keep a carry and continuously add till we get a final linked list. Okay, so the question mentioned that the numbers are already reversed. Okay, if similar question comes but there's no reversal, in that case what you have to do is you have to reverse this linked list first, then you can add. Okay, so let's see the first method to solve this question. This method is going to take a time complexity of maximum of m or n, which of this linked list is bigger, and space complexity same as the previous one, maximum of m or n. Okay, the core idea behind all of these methods is going to be almost the same. Okay, because basically we are adding two numbers. Okay, the caveat is that we have linked list in place of directly integers. Okay, that only creates a bit of problem while adding these numbers. Okay, so basically the core idea behind is going to be, first we are going to add, then we are going to create new node, we are going to insert this digit, then we're going to update our carry, and we are going to repeat this process till we hit a certain case. Okay, let's see what the three distilled cases that we can see. Okay, these distilled cases are first, if both of these nodes have some list in future to process. Okay, this is going to be a first case. Second case, one of these lists have ended and second is yet to process. Okay, this is the case where you can see here that this list 1 is way larger than list 2. Okay, so list 2 will end before list 1. Okay, so while adding 9 plus 9, 9 plus 9, 9 plus 9, and 9 plus 9, after this, there's no number for linked list 2, but there's still numbers in linked list 1. Okay, in that case, we have to handle differently. And third is only a carry part is left. Okay, so there could be a case where we add these two lists and we have this 3 plus 7 or 3 plus 8 in the end. Okay, in that case, we have a carry left which we have to handle separately. Okay, and for each of these sum, this is going to be the same template for all of these. Okay, the sum is going to be existing list plus carry, existing list from each of these cases. The digit is going to be some percent in, and carry is going to be some divide by 10. Sorry, this is written wrong, some divide by 10. Okay, now let's see the visualization part for this one. So initially the carry is going to be 0. This is my linked list, this is a bit changed. Okay, now you can see initially the sum is going to be 2 plus 5 plus 0. Okay, the first nodes 2 plus 5 plus 0 because carry is 0, which is going to be 7. 7% 10 is going to 7, and carry is going to be 7 divided by 10, which is going to be 0. Okay, so current carry is 0 and current digit is 7. So to store a new linked list, what you're going to do is we're going to create a dummy variable and we are going to introduce a tail and we're going to create this new node and point it through dummy so that we can in the end return this whole list. Okay, so we have digit inside this new node and we have carry as 0. Our tail points to this node. Okay, next iteration we have 4 and 6. Okay, so 4 plus 6 plus carry is 0 is going to be 10. Now 10% 10 is going to be 0. Okay, so the digit is going to be 0 and carry is going to be 10 divided by 10, which is going to be 1. Okay, so current carry is 1, our digit is 0, we are going to store 0, we are going to move the tail pointer. Okay, and a new carry is going to be 1. Okay, next iteration where uh, this iteration where we have 3 plus 7. Okay, so 3 plus 7 is going to be 10 and carries 1. So 3 plus 7 10, 10 plus 1 is 11. So digit percent 11 is going to be digit is going to be 11% 10, which is going to be 1, and carry is going to be 1. Okay, so tail is going to be point this is wrong. Tail is going to point to this pointer, and we we have added this one. Okay, now you can see the both of these lists have ended, but we still have a carry left to process. Okay, so in that case, we'll add this carry in the end with a single int entry, because we know even for the biggest digits 9 plus 9 is equal to 18. So 8 will be stored here and 1 will come in this place. Okay, so carry can only be 0 or 1. Okay, hence we'll directly append this carry in the end of this list. Okay, and tail is going to point to this pointer. This is also wrong. Okay, so let's see how we are going to code this method. Okay, so initially we'll need a dummy to store a list node dummy of 0, list node star tail is equal to address of dummy. Now we'll need two pointers to iterate over lists. So list node star temp1 is equal to L1. List node star temp2 is equal to L2. Okay, now what we're going to do is we'll have this case one. Okay, this case one, both lists have some node. Okay, so while temp1 and then temp2, this is same as writing while temp1 is not equal to null and temp2 is not equal to null. Okay, I'll proceed them early. So temp1 is equal to temp1's next, temp2 is equal to temp2's next, because I know I will forget this, so I'll write it initially. Okay, now I'll have int sum is equal to temp1's value plus temp2's value plus carry. Okay, so you can see we need a global carry too. Okay, since carry is going to move forward for each of these iterations, so we need a global carry. We cannot uh, recreate carry for each iteration. So carry is equal to 0. Okay, now we'll need a digit. So digit is equal to some percent 10. Carry is going to update to some divide by 10. Okay, now I'll create a new list node. Star node is going to be new list node. It's going to store digit. Okay, it's going to store digit. Next, tails. Next is going to point to node. Tail is equal to tails next. So I have updated tail too. Okay, now this is complete for the sum. We have sum digit carry. Okay, now for these cases. Okay, cases where one of these lists is empty and there's only one list left to process. In that case, we'll have another while loop. So while temp1. Okay, so this represents that temp2 was shorter one and temp1 still has some numbers left with it. Okay, I'm going to copy this and tell this, and we're going to use the same template. Okay, and we don't need val2 because val2 is empty. Okay, the sum is going to be temp1 plus carry. We have digit and update our carry. We'll build a node, insert this digit, update tail, and move temp. Okay, again for temp2, because we don't know which one of these list is longer or shorter. In that case, we'll have this one, this case. Okay, so sum carry digit, same thing, everything is same way. Okay, so we have done this, we have done this. Now the fourth case is going to be if we have carry left after all these caveat. Okay, We have solved temp1, we have solved temp2, we have solved them combined format. Now in the end, for this carry, what you're going to do is we are going to just insert this in the end. So tails next is going to be new list node and carry. Okay, so this is going to insert a new node like this. This is going to insert a new node inside n, which is going to carry which is going to have value carry. Okay, and carry is going to be obviously 1. So if carry is 1 after all this procedure, then it's going to be inserted inside this new inside this list. Okay, in the end we have to return dummy dot next. Okay, so this should do it. Let's run this code. Okay, let's submit this. So to solve this question using iterative approach, this approach takes time complexity of basically of O of n and space complexity of O of n. Okay, so that's it. Let's see for the next method. Okay, now that we have seen the iterative approach to solve this question, let's see how we can optimize this method. Okay, so you can see this iterative approach, it takes this temp for case 1, for temp1 and temp2 for case 2, and in the end carry for case 3. Okay, what you can do is we can optimize this all in one single while loop. Okay, let's see how. Okay, so basically you can see here that these were the three cases that we were handling isolated. Okay, this time what we are going to do is we are going to handle all of these cases in one go. Okay, let's see how. So this method, what we're writing is while temp1 or temp2 or carry. Okay, if any of these three is available, in that case what we have to do, let's see. So first thing, let's comment this out. Okay, so that we are not interfered, and you have to see that these are still going to be there. Okay, we are just modifying for these 3 4 while loops, okay, that we are running. We are modifying them so that we can write them in one single loop. Okay, so first thing that we can see that sum is going to be carry. Okay, sum is going to be initialized with carry. Next, carry can be 0, can be 1. So we have already added carry with a sum. Okay, now it's going to be, I'll add sum with temp1's value, but before adding it, I'm going to check if temp1 is null or not. Okay, so I'm writing this ternary operator. Okay, if temp1 exists, then add temp's value, else I'm going to add 0. Okay, same way for temp2. Okay, if temp2 exists, in that case temp2's value, else add 0. Okay, so we have finally have sum. Now I'll calculate digit. So digit is equal to sum percent 10, and carry is going to be sum divided by 10. Okay, after this we just have to point out with or we have to create a new node and we have to insert digit. Okay, so list node star node is equal to new list node and insert digit inside it, and then we'll point using tail. So tails next is equal to node, and tail is going to move to next pointer. So tail is equal to tails next. Okay, and after these we don't know if we took the value from temp1 or not. So if so, you can see in the above loops that if we use temp1's current value, you have to move temp2 next value. In this case, where both of these exist, in that case we have to move both of these. Okay, but in this loop we don't know which one of them exists, so we are going to check them. If temp1 existed, or you can say temp1 is not equal to null, you can write it like this. In that case, we are going to do temp1 is equal to temp1's next. Same way for temp2. When if temp2 is not equal to null, then we are going to move temp2 to 2. Okay, because if they were not null, then their values are being processed. Okay, if they were null, we don't have to move them. Okay, and in the end, that should solve a problem. And since we are using tail and dummy in this case, hence we can use dummy.next to return this list. So return dummy.next. Okay, so this should return, and we have moved temp, we have created a node, we have connected it, we have calculated it. Okay, so this should do it. And you might think that if carry part, how it's being handled, you can see if temp1 is null and temp2 is null, but still if carry is equal to 1, in that case this while loop is still going to run. Okay, so let's run this. Okay, so let's submit this. So this was the optimization part. Next, we are going to see recursive approach. Okay. So till now we have seen the iterative approach to solve this problem. Now we are going to see a recursive approach. Okay. Although I have been through a lot and I have optimized this recursive approach to work with the same iterative approach. Okay. So basically you can see we in the last part we optimized this, we had this optimized code. Okay. This time I'm going to reuse this code to solve this question recursively. Okay, so this is not going to be like a lot of recursion rather than just one call, and that call is going to recursively call itself. Okay, so I'm going to remove this, and then I'm going to write a void function. Okay, void solve. This function is going to take list node star temp1, list node star temp2, list node star and tail. Okay, so I'm passing this by reference. Okay, and int and carry. Okay, and carry. So after these four inside my void function, now I'm just going to paste this function that we wrote previously. I'm going to call it as if we hit any of these cases, and in that case we are going to run the same thing, because it's like there's nothing that's going to break here. If this temp1, then only then there's going to be addition of temp1. If this temp2, then and then only there's going to be addition. Okay, so this is like completely foolproof code. Next, I'm just going to write a solve temp1, temp2, tail and carry. And you might write a return in the end because it's a void function, but it's not needed. Okay, so you can see I've updated my temp through this and this. I've updated temp2, I've updated tail through these, and I've also updated carry through this. Okay, so there's no need to update here. All the things have been updated here. I just have to run this function. So to run this function, I have to call it through this, and I have dummy and I have tail. I have these temps. I have initialized carry. You have to initialize. You cannot directly pass 0 because we are passing it by reference. Okay, and what you can write is solve temp1, temp2, tail and carry. Okay, after passing these you can just directly return dummy dot next. Why? Because since we are passing this by reference, not by value, so this tail is actually going to point to uh, this dummy is going to point to right list. Okay, so let's run this. uh, let's submit this. So basically we have reused this function that we wrote in the last time that we were optimizing for iterative code. Although there's also recursive code which is like this long, where we use for both temp1, temp2, temp1 and temp2. So we have separate conditions for each of these, but clearly we can see that we can use this single check condition, and then we can proceed with a recursive solution. Okay, so that's it. Let's code the last one, which is going to be the in-place approach. Okay, this approach is going to take a space complexity of O1. So this is going to be the one of the most optimal solution, although there's a caveat with it. Okay, let's see in that one. So till now we have seen a lot of copy pasting, and we have basically solved this question using literally one method, but we have seen three different versions of the same method. Now we are going to use a fresh method. Okay, this is going to be in place approach, which is going to take time complexity of m or O of n, and space complexity of O of 1. So this is the solution which is having space complexity of O of 1. Okay, so what do I mean by in place approach? The in place approach means that I'm going to modify the linked list that are being provided to me by the function. Okay, so that's the main caveat, that the question should allow me to modify the existing list. That's the only way I can use O of 1 space complexity, else I have to create a new list which is going to take O of n space complexity. Okay, so let's see how this in place approach is going to work. You might have noticed that I kept this get length function with me in comments for like whole video. Let's uncomment this and read this. This is the simple getLength function in which we are going to pass the head, and it's going to calculate the total number of like nodes inside this linked list. Okay, it's a simple function. There's nothing about it. So the main idea behind this method is going to be, you can let's see here. Uh, these two lists are of same size. Okay, so we can choose any one of this to fill the values. Okay, but let's say for example like this L1 is clearly way larger than L2. Okay, in that case I'm going to choose L1 to fill it. Okay, I'm not going to choose L2, I'm going to choose L1 to fill it, because in that case I don't have to create a lot of nodes. Okay, in that case I just have to keep updating this L1, and if there's a case that there's a remainder or a carry in the end, then I'm going to insert one simple node. Okay, other than that there's no need for extra node, because even after filling these with these values, we just need an extra node here. Okay, all these values can fit inside this single L1, and this is just an extra node that we need for keeping carry. Okay, so this is going to be our main ideology behind this method is going to be, I'm going to calculate the lengths. So length 1 is going to be for list L1. Okay, so get len L1. Next, int len2 is equal to get len L2. Okay, so now I have calculated the length of both of these lists, and now I'm going to check if len1 is less than length 2. Okay, in that case I'm going to swap length 1 or L1 with L2. Okay, so this swapping is part of C++ STLs. Okay, so it's directly going to help me swap this list 1 with list 2. Okay, now once we have L1 as the bigger list, now what we need is two things. We'll need a list node star head, which is going to store my L1, so that while I'm moving L1 I can still have head with me. Okay, next is going to be list node star, you can say tail. Okay, which is currently pointing to null pointer ptr. Okay, now we'll have while L1 or L2. Okay, if any of these exist. Okay, so int sum. Okay, we also need a carry, so int carry is equal to 0, and sum is going to be initialized with carry. Okay, now if L1 exists, then we are going to add L1, sum plus equal to L1's value. Okay, If L2 exists, so if L2 is not equal to null, you can write it as if L2 sum plus equal to L2's value. Okay. Now after both of these, what you have to do is we have to calculate digit. So int digit is equal to sum %10 and carry is going to update to sum divided by 10. Okay. Now, once we have done this, we have to update this digit value inside L1 itself. Okay. So L1's value is equal to digit and tail is going to be pointing at L1. Okay. So we have tail pointing to it and we have updated the value of L1. Okay, why we are keeping this tail is because in a certain case where we have this carry 1 left with us, in that case we can directly fill the value 1 at the tail. Okay. And the last part is if okay, this is not if L2 exists. Okay, if L2 exists, in that case we are going to move L2 to L2's next. So L2 is equal to L2's next. Okay, and we obviously have to move L1. So L1 is equal to L1's next. Okay, so this is going to be it for this function. In the end, we have to handle carry. So if carry still exists, in that case, tails next is going to be a new list node and carry. Okay. And in the end, we have to return head. This is the reason we stored head, because we are directly modifying L1 and L2 and we don't have dummy in this case, so we have to store a head separately. Okay, and let's run this, see if there are errors in this one. Okay, so let's submit this. So you can see we don't have to create any extra node inside this while loop, and there's just need for creating one if there's a carry. Hence this method can be considered as of one space complexity. Okay, so that's it for the video. Thank you.